Okay, so for another tricky example, let's suppose I give you guys y is equal to the 7th root of x cubed. If we're asked to take the derivative, it's a lot easier to do this if you guys recognize that this can be rewritten as x raised to the 3/7 power. So something we've learned in the past is that a to the m over n power is the same thing as the nth root of a to the m. So just using this rule, I was able to rewrite my expression like this. So then I can just use the power rule. So since it's y, the derivative is going to be dy dx is equal to, take the power and bring it to the front. So then there's a 1 in the front, so 3/7 times 1 is 3/7. X to the power of 3/7. Power rule, you're going to subtract 1. So that's the same thing as 3/7 minus 7/7, which is giving me negative 4/7. Okay. A lot of times we're going to want to rewrite this using a fraction. So 3 and 7, 3 stays on top and 7 goes on the bottom. This is going to be x to the power of, whenever we have a negative exponent, remember I can bring it to the bottom. So this is going to be x to the 4/7 power. And a lot of times you can leave it like that. Or if you want, you could rewrite it as 3 over 7 times the 7th root of x to the 4th. Both of these you want to be comfortable with, because if this is a multiple choice question, you want to be able to recognize that these are the same answer. All right, part B. Say I give you guys h of x is equal to x all over square root of x. Okay, a trap you don't want to fall into is that when you have a fraction, the derivative of the function is not the derivative of the top divided by the derivative of the bottom. We have a rule for division of two functions, and you guys will learn that this coming week. What I could do, though, is realize that x is the same thing as x to the first. Square root of x is the same thing as x to the 1/2. So remember, when you have the same base divided by, when you're dividing two things with the same base, you're going to subtract the powers. So this is just going to become x to the power of 1 minus 1/2. So this is just x to the 1/2. So then power rule, h prime of x is going to bring the 1/2 down. So 1/2 x to the power of, subtract 1 from the power, you get negative 1/2. So this is going to be 1 over 2. And then the negative exponent, I can bring this to the bottom. So this will be x to the 1/2. So this is the same thing as 1 over 2 square root of x. All right, let's do one more and then we'll move on. C. So let's say I gave you guys f of x is equal to 5x cubed minus 3x squared plus 4x plus 8 all over x. Okay, so kind of like the last example, you have a division on top. You have a function on top, a function on the bottom, and you're dividing. This is not the derivative of all this divided by the derivative of this. So what I could do is, because there's one term on the bottom, what I could do is just divide each term individually by x first and then take the derivative. So f of x is going to be the same thing as, if I take 5x cubed and divided by x, it'll be 5x squared minus the next term divided by x would just be negative 3x plus 4 plus 8 over x. Nothing cancels because there's no x here. And then remember, before I do the power rule, that this is the same thing as 8x to the negative 1 power. And by recognizing that, it allows me to take the derivative a little bit easier. So the derivative, f prime of x, just do the power rule on each term. So it's going to be 10x minus 3. Remember, the derivative of a constant is just 0. The derivative of this, bring down the power. So it's going to be negative 1 times 8, which is negative 8. X to the power of negative 1 minus 2 sorry, negative 1 minus 1 is negative 2. I'm thinking ahead. Now this right here, because it's a negative exponent, I can just rewrite this as 10x minus 3 minus 8 all over x squared. All right, next idea, horizontal tangent lines. So remember, horizontal lines look like this. So if I was asked you guys to, that looks terrible. Go away, go away, go away. If I asked you guys to find the slope of this line, m would equal 0. So a horizontal tangent line is any point on the graph where the slope is 0. So here's a horizontal tangent, here's a horizontal tangent. So if you're asked to find values where there exists a horizontal tangent line, remember slope means derivative. So you're just looking for anywhere where the derivative is equal to 0. Okay. Next idea, normal lines. So a normal line to a curve at some point x is perpendicular to the tangent line. So remember, the tangent line is y minus y1 is equal to m times x minus x1. So the normal line is the same thing, y minus y1 is equal to, remember in pre-calc, we would take, to find the perpendicular slope, you would take this, flip it upside down and change the sign. So it'd be negative 1 over m times x minus x1. Well, remember that this is just the derivative at the x1 value, okay? Now in this class, we're going to be dealing a lot with applications of derivatives, and one of those is a physics application, which is velocity and acceleration. So if you have just an f of x function or f of t, this represents the position function. Once you start taking derivatives, then they represent different things. So the first derivative, f prime of t, represents the velocity function. And then the second derivative, which we'll abbreviate as f double prime of t, so f prime, f double prime, represents the acceleration function. You don't have to be an expert at physics to understand this. Just all I need you guys to remember is first derivative is velocity, second derivative is acceleration. Okay, so next example. Find all points on the graph where f of x is equal to 2x cubed minus 12x squared plus 1 has a horizontal tangent line. So remember, this just means the slope is 0. What does slope mean in our class? Slope means derivative. So I need to take this function, take the derivative first, and then figure it out from there. So first step is always going to be take the derivative for these type of problems. So f prime of x is equal to, this is just a polynomial, so just power rule. So the derivative is going to be 6x squared minus 24x. And just remember that the derivative of a constant is just 1. So what I'm going to do is I'm going to set my function now equal to 0. Okay, GCF is 6x, so 6x, that looks bad. 6x times x minus 4 is equal to 0, which means that 6x is equal to 0, or x minus 4 is equal to 0, which means that x is equal to 0, or x is equal to 4, okay? So these are the two x values where if I graph this function, this is where there'd be a horizontal tangent line. So the curve's maybe doing something like this, and it's gonna be 0, 0, that's what that means. So we know the x values. To find the y values, I need to take each point and plug it into my function. So f of 0 is gonna be 2 times 0 cubed minus 12 times 0 squared plus 1, and that's just 1. F of 4 is going to be 2 times 4 cubed minus 12 times 4 squared plus 1. 4 cubed is 64, times 2 is 128. 4 squared is 16. 16 times 12 is negative 192 plus 1. And I want to say it's negative 63 from my notes. So that means the 2 points are going to be, we plugged in 0 and got 1, and we plugged in 4 and got negative 63. Okay, so since I'm recording this on the video and we're not in class, I can actually show you guys what this looks like. So if I graph this, 2x cubed minus 12x squared plus 1. Now, what I want you guys to notice is kind of cool is right here at x equals 0, if I drew a line through that point, 0, 1, there would be a horizontal tangent line. And then way down here, we're going to have a minimum. And where's it at? 4, negative 63. So same thing, if I drew a line to that point, 4, negative 63. So let's show you guys y equals negative 63. The derivative is 0 there. And y equals 0. Let's scroll back up. Oh, not y equals 0, y equals 1. There we go. Horizontal tangent line at y equals 1 and x equals 0. So that's pretty cool. Okay, next problem. Find equations of the tangent line and normal line of f of x is equal to 1/2 x squared minus 4x at x equals 2. Okay, so tangent line, remember y minus y1 is equal to m times x minus x1. So remember the x1 is just whatever x value I tell you, so that's 2. The y1 comes from, if I take my x value and plug it in for x, that will give me y1. So I need to find y1 first. So right now, this is the only thing that I know. So I need to find y1. So f of 2 is equal to 1/2 times 2 squared minus 4 times 2. 2 squared is 4. Half of 4 is 2. 2 times 4 is 8. So this is negative 6. So this is my y1. To find my m, I need to take the derivative of my function and plug in 2. Now, in the first lesson of this unit, you had to do the difference quotient first. Now that we know the power rule, we can just do the power rule. So f prime of x is equal to, power rule, bring the 2 down. 2 times 1/2 is 1, so this is just x. And then the derivative of negative 4x is just negative 4. So to find the slope at that point, I need to plug in the x1 value. So f prime of 2 is going to be 2 minus 4, which is negative 2. So this is my slope. So now, plugging into my tangent line, y minus negative 6, so y plus 6 is equal to negative 2 times x minus 2. Right? Yeah. So this is my tangent line. To find the normal line, it's literally the same answer. The only thing we have to remember is that the slope for this guy is going to be perpendicular. So the negative reciprocal of this is going to be positive 1/2. So the answer is going to be y plus 6 is equal to positive 1/2 times x minus 2. So I'll leave a little note that this right here and this right here, they are perpendicular. So find the opposite reciprocal. So you really just need to do the work once. Once you find the tangent line, then to find the normal line is really easy by just remembering that rule. Okay. Now, because we're on the video and I don't have to worry about time-wise, I'm going to graph this and show you guys what this looks like. So if I go back to Desmos, get rid of the last problem. So we had f of x is equal to 1/2 x squared minus 4x. So x equals 2. We had the point 2, comma. When we plugged in 2, we got -6. And there it is on the parabola. Okay. So then what I'm going to show you guys is the slope of the line through that point should be the tangent line. So it's going to be y plus 6 was equal to -2 times x minus 2. And there it is. There's that red tangent line. And you guys see as it gets closer to the point at x equals 2, it's crossing the point on the parabola. And then it kind of just goes away. It doesn't cross again. It crosses the parabola just at that one point, and that's it. Okay. Now, geometrically, we can see the normal line too. So if I just erase my slope and change it to 1/2, we have the perpendicular slope too. Let me change the color, make it blue. And then let me make this a little bit bolder. There we go. So geometrically, it does look like that red line and the blue line are crossing at a 90-degree angle, which means it is normal. And also our normal line crosses that point 2, comma -6. So geometrically, that's what that looks like. So that's what you're really finding. All right, next problem. So we're given a position function, s of t. So we are asked to find the acceleration function. So we have to find the acceleration function and then use that to figure out what is the acceleration at t equals 2. So one thing we have to pay attention to also in these type of problems is the units. So s of t is in centimeters and t is in seconds. So to find the acceleration, I need to do the second derivative. So like I said in class, there is no way to go from this straight to s double prime of t as like a shortcut. I have to do one derivative at a time. So s prime of t, using the power rule, is going to be 6t squared minus 10t plus 3. So this is velocity because it's the first derivative. And technically, I could say this. This is the same thing as v of t. That looks bad. V of t. There we go. Now, to find the second derivative, s double prime of t, that's going to be a of t. And a of t is the same thing as derivative of velocity. So they're all the same thing. Power rule. Power rule, this guy is going to be 12t. Oops. Switch back to the pencil. 12t minus 10. So second derivative, this is acceleration. So this right here is velocity. And then a of t is acceleration. So now, so this is my acceleration function. So a of t is equal to 12t Okay, so then to find the acceleration at t equals 2, all I have to do is take 2 and plug it in for t. So to show your work, you're going to say a of 2 is equal to 12 times 2 minus 10. 12 times 2 is 24, minus 10 is 14. We need units though. So the first derivative is a rate of change. This would be centimeters per second. Since it's a second derivative, it's the rate of change of the rate of change. So this is going to be centimeters per second squared. All right, last example. Is the function f of x, which is equal to 5x squared plus 3x plus 2 when x is less than -1, and then negative 7x minus 3 when x is greater than or equal to -1, differentiable at x equals -1. All right, so these problems are kind of long. They're not hard, they're just kind of long. So what we're going to do first is we need to figure out, is it continuous? So in the last lesson, we learned that if a function is differentiable, it has to be continuous first. So just like we did in Unit 1, to prove something is continuous, I need to do the left-hand limits and right-hand limits and make sure that exists, the limit exists, and that the function value at the given value is the same as the limit. So for show your work, so step 1 is f of x continuous at x equals -1, question mark. So first thing you need to do, does f of -1 exist? It does, because we have some place right here where it's equal to -1, and so that means I can plug into the bottom function. So it's gonna be negative, oh my goodness. It's gonna be -7 times -1 minus 3, that's just 4. Next thing you have to show is the limit as x approaches -1 from the left of f of x equal to the limit as x approaches -1 from the right of f of x. So the limit as x approaches -1 from the left of f of x, plug into the top. So 5 times -1 squared plus 3 times -1 plus 2. -1 squared is 1. 1 times 5 is 5. 3 times -1 is -3 plus 2. 2 plus 2 gives me 4. Now the limit as x approaches -1 from the right of f of x, we already plugged this number into the bottom function. This is the right-handed limit, so I'm okay with you guys just saying it's 4. So biggest thing you have to worry about is this is the same as this. So therefore, the limit as x approaches -1 of f of x is equal to 4, because the left-handed and right-handed limits agree. Then last thing, is f of 1 equal to the limit as x approaches 1 of f of x? Yes. F of -1 was 4. The limit as x approaches -1 is 4. So because these two things are true, we can say, therefore, f of x is continuous at x equals -1. So if this wasn't true, then we could just stop the problem, because if it's not continuous, it can't be differentiable. So the next thing we have to show for the differentiability part I need to take the derivative of my function. So we were given f of x is equal to 5x squared plus 3x plus 2 when x was less than -1, and negative 7x minus 3 when x was greater than or equal to -1. So what I need to do is I need to take the derivative of the top and the derivative of the bottom and then plug in -1 into both. So f prime of x is equal to, the derivative of the top is going to be 10x plus 3. And we're going to keep the same condition. The derivative of the bottom is just going to be -7. So what we just need to show is this, there's nothing to plug -1 into because it's just -7. So if these are going to agree, if the limits are going to agree, then I just need to plug in -1 into here and hope it equals -7. So the limit as x approaches -1 from the left of f prime of x is going to be 10 times -1 plus 3, and that's -7, which is the same thing as the limit as x approaches -1 from the right of f prime of x. So because those are the same, I'm going to shrink this so everything fits. Give me a second. So because of the same, therefore, f of x is differentiable. Oops. At x equals -1. Okay. As long as you understand this, the way you guys write up this type of problem isn't like super as important as this part. This part is super important. You guys label it as like steps 1, 2, and 3, because this might be like an FRQ type question. This might be, to be honest, it might be 1, 2, but as long as you show that they exist, you're going to get the points. Okay. And that's it, guys.